Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. We are from Group C. We'll be presenting the status of Lajak Kuruih C tablet production in December 2020. Our group member is Zairee bin Muhammad, which is me, Raja Muhammad Farhan bin Raja Abdurrahman, and Muhammad Hairudin bin Mad Ali. I will be presenting Part A and Part B. Okay, for Part A, it is about summary data for 200 pills Lajak Kuruih C. From available data that we receive, I have summarized it into numerical form table, which is shown in this slide. All data are divided into 3 shifts, which is morning, evening, and night shift. Each shift has 3 parameters recorded, which is tablet weight in milligram, density in percentage, and its tensile in megapascal. For above table, it shows the sum of data, and below table shows the average of the data. For this slide, showing the graphical form of sum of data and also the graphical form for average of the data. Next is the data that I make it in tabular form, where the tablet parameters has its own row label or range. Each parameter range also has its own frequency. This is tabular form for weight distribution, relative density, and also tensile strength distribution. So for Part B, I will be explaining about hypothesis of the data. Okay, for hypothesis of the data, step 1, we need to make a hypothesis statement where H naught is equal to X follow the distribution and HI or alternative hypothesis equal to X not follow the distribution. From the questions given, the Food and Drug Administration or FDA requires that weight standard tablets produced should be normally distributed with 350 milligram with standard deviation of 14 milligram. The question is whether the data is following the requirement. By using goodness of fit test method, I put the weight parameter into 5 class of interval table with its frequency for each class of interval. Step 2 is to find chi-square test value by using the formula of summation OI minus EI square divided by EI, where EI is expected value equal to N multiplied by PI, where PI is the probability. After getting the probability value, we will get expected value for each of the class interval, as we can see in this table. From the obtained value, we need to verify that the test is only applicable when EI value is greater than 5. Therefore, we need to combine the data for expected value 1 with expected value 2 and expected value 4 with expected value 5. On the new table, then we will get a new chi-square test value. Step 3, we need to find critical value by using chi-square alpha k minus 1 with 5% level of significance. From the obtained critical value 5.9915, which is obtained from statistical table, we can plot the graph using these 2 values, and we can see that the critical value is larger than chi-square test value. And for the decision at alpha equals 0.05, we will reject H naught if chi-square test is larger than critical value or X square alpha k minus 1. Thus, we fail to reject H naught and conclude that there is no evidence to support the weight of Lajak Kuruih diet tablet do not follow the normal distribution with a mean of 350 milligram and standard deviation of 14 milligram. We now have a significant evidence that show this diet tablet following the distribution required by the Food and Drug Administration or FDA authority. That's all for my presentation. Thank you.
Assalamualaikum warahmatullahi wabarakatuh and good day. My name is Raja Muhammad Farhan and I will explain about part C in this task. I will give a comment on whether there is any significant difference between tablet weight in milligram from the different shift. We go on the method. Okay, first, by using one-way ANOVA in Microsoft Excel, to decide if there was any significant difference between tablet weight from the different shift. We can see the hypothesis test. Later we discuss on this hypothesis test. Okay, we go next slide. Okay, by using Microsoft Excel, we will instantly get the following result or output. Let's understand the output, the summary given, or the descriptive statistical summary on the group data, where the first column in the summary refers to the group morning shift, evening shift, and night shift. The second column on the count refers to the levels and the size Ni. We can see N for morning shift is 61, N for evening shift is 71, and N for night shift is 68. The total sample size, capital N, is not given though, but we can always calculate on our own, where capital N is simply the sum of all Ni values, which is 200. The summary table also gives us the level variance in the last column. The next table is the one-way ANOVA table. The F value here is the calculated F ratio, whereas the F crit here is the right side critical value F, and the alpha equal to 0.05, and the degrees of freedom 2 and 197 given by 3.0418, which is correct for decimal places. An extra value given by Excel is the P value, which is the probability value that the F random variable is greater than the calculated F ratio. We will see later how to use the p-value in the alternative decision rule when performing the statistical hypothesis testing in a one-way analysis of variance. Using the Excel output, we still need to complete the testing procedure by stating the hypothesis statements H0 and H1 decision rule, decision statement, and conclusion. The solution starts with H0, where on the H0, the means mu1, and this the hypothesis, mu2 and mu3 are all equal, whereas on the H1, mu I is not equal to mu j for at least one ij. Since Excel output gives a p-value defined by the probability that a random variable f is greater than or at least equal to the calculated f ratio, we can actually use this p-value in the decision rule, where instead of comparing the test statistic value, which is the calculated f ratio, with the critical value, we can actually compare the p-value with the level of significant alpha directly in the alternative decision rule. Therefore, the alternative decision rule, when using the p-value, is to reject H0 if p-value is smaller than the level of significant alpha, which implies that the calculated F ratio is larger than the right-sided critical value. The conclusion will be exactly the same when we use any of the decision rule. We can use the p-value from Excel output to make statistical decision. We will reject the null hypothesis H0 if the p-value is smaller than the level of significant alpha, which is equal to 0.05. Since the p-value given by Excel is 0.8355577872, which is much greater than 0.05, then the decision is not to reject the null hypothesis H0. The conclusion that at alpha equal to 0.05 level of significance, that there is no significant difference between tablet weight in milligram from the different shift. By making the conclusion, we have completed the comment on the statements. That's all for part C. Thank you.
Assalamualaikum warahmatullahi ta'ala wabarakatuh. Salam sejahtera. Hi everyone. I am Hairudin, become the last presenter for this group. We'll present for part D, linear regression models. At first, I would like to explain the predicting the tensile strength and relative density of Lajak Kuruih C. This table shows the sample of 200 data from month of December for relative density in percent and tensile strength for MPa. Okay, we got finding the have relationship between the tensile strength of the pill and relative density regardless of the shift. For other view, the tensile strength is dependent variable and the relative density is independent variables. We also conduct the linearity test to check the relationship between two elements is linear or non-linear. Okay, the result is 95% confident in the linear relationship between the tensile strength of the pill. Our relative density is valid, and we also can use equation to describe the relationship by using y equal to mx plus c. We also analyze regression statistics by using Microsoft Excel data analysis. The output of the summary result as shown is these tables. When we input the register statistics with observation 200 data, we call as N, we can go ANOVA tables, output data, and also t-test data. And based on this table, the coefficient alpha H and coefficient beta H shown is this. And then back to the equation, y equal to mx plus t, and based on summary output data, we can get the result of the y as follow. From the equation y equal to mx plus c and summary data output from register statistic tables provided by Microsoft Excel, we can get alpha H and beta H value. Okay, so we can calculate value of y when x is 68%, so y become 5.4014, while when x become 74.3%, y is 5.9490, and then when x is 80.1%, y is 6.4532. Next page is output graph, which is generated by Microsoft Excel for linear regression model for this analysis. Okay, first graph, you can see relative density in percent line profit, which is blue color is tensile strength and yellow color predict tensile strength. Second page is relative density in percent residuals, and the last graph is normal probability. And last one, we can conclude this analysis as follow. The table weight follow normal distribution mean equal to 350 mg. Standard deviation is 14 mg. There is no significant difference between the tablet produced in different shifts. And lastly, for prediction is relative density value if compared with tensile strength when 68% is 5.4014 MPa, 74.3% is 5.9490 MPa, and last one 80.1% relative density value tensile strength is 6.4532055 MPa. Thank you for your attention. Hope we can see you again. Have a nice day. Bye.